Alright, so now we're going to do dividing fractions. And with dividing fractions, this is kind of weird, but the general idea is you're going to take your first fraction, which is 2/3 in this case, you're going to change your operation to multiplication, and then you're going to flip the second fraction over. So you're going to do what we call multiply by the reciprocal. This isn't the video where I go into length about why that is. I have a video on that, but in this video I'm just kind of giving the nuts and bolts of the idea. But basically we are dividing by division, which kind of reverses things on us. That's the short version of the story. Because it's like two rights make a wrong, two wrongs make a right. I don't know how the saying goes. Anyways, two divisions make multiplication. That I do know. Alright, once we get it flipped around and changed to multiplication, then it's like the multiplication problem we just saw. I don't have any numbers that will divide in the top and the bottom the same. Now I do have 2 3s in the bottom, but you can't divide the same thing out of the bottom twice. You can only divide the same thing out of the top and the bottom once each. So what I want to do here is go ahead and do the multiplication across the top. That's going to give me a 10. And then do the multiplication across the bottom. 3 times 3 will give me a 9. And I get 10 9ths. So at this point, whether or not you leave it as 10 9ths or convert it to a mixed number is a question for your individual math teacher. I like these. They're called improper fractions when the top is bigger than the bottom. That's my preferred way of expressing it. But if you want to convert it to a mixed number, then that's going to be 1 and 1/9. And there's a routine for doing this, but I want to think about what's happening. I've got 9ths. So I have things that are like, if I have 9 of them, I have a whole, right? So this is telling me what size of things I have, and this is telling me how many I have. So if I have 9 of these things, I have 1 whole pizza. Well, that's my 1 there, okay? Because I do have 9 of them, I have 10. And so then I have 1 left over, and I need to still communicate what size that one is, because it's not a whole. So that's the idea conceptually speaking, and that's what I tend to do in my brain. I don't just do the algorithm, so to speak. But the algorithm is to take 9, and you're going to divide this into 10, like old school division. 9 goes into 10 one time. And then 9 times 10 is 9, bring this down, and you have a remainder of 1. This is where it gets confusing because I have multiple 1s going on here. This is the 1, it went in there 1 whole time. It had a remainder of 1, and then my denominator, of course, just stays the same. That's what I'm dividing by. So that's the algorithm, but I think of it in terms of how many wholes can I make out of 10 if I have things, if 9 of them make a whole. Well, 1 of them. I'm going to have 1 left over.